Good morning, dear student. In previous lecture, we already discussed uh, the different mechanism for the substitution reaction in octahedral complexes, such as associative, dissociative, interchange, and the evidences uh, for the dissociative type of mechanism. So, in today's lecture, we are very much interested in the stereochemistry of this substitution reaction. So, for this stereochemistry of this octahedral substitution reaction, we will discuss the first one, that is substitution in trans complexes, and what is the product after substitution. What type of isomer we get, either we get trans or mixture of cis and trans. Okay, so we will discuss it in uh, we will discuss in this lecture. So let us consider the first one, that is substitution in trans complexes. So if you consider beyond the possibility of the conjugate based mechanism, so we already discussed one of the evidence for this dissociative type of mechanism, that is conjugate based mechanism. So beyond the possibility of this conjugate based mechanism, substitution of y for x, so substitution substitution of y for x. So what is y? Y is your incoming nucleophile and x is your the ligand which is leave the complex. Okay, so it is the ligand which is dissociated. X is your ligand which is dissociated, and y is your incoming nucleophile. So beyond the possibility of conjugate based mechanism, so we already discussed the conjugate based mechanism for this dissociative type of reaction. Okay, the substitution of y for x, so the incoming nucleophile take the position of this x. So substitution of y for x in trans complex. So we discuss the substitution, that is stereochemistry of substitution reaction in trans complex, that is trans m ll by 2 bx. Okay, this is your octahedral complex where this ll twice is your bidentate ligand. Okay, so this ll twice is your bidentate ligand. So we take ll as a en, ethylene diamine. Okay, ethylene diamine is your bidentate ligand. Okay, b is one of the ligand and x is your the ligand which is dissociated from this trans complexes, and y is your incoming nucleophile. Okay, so if you consider the stereochemistry or substitution in this complex, that is trans mll by 2 bx. Okay, it can be proceed by three dissociative pathway. So the substitution occur by three dissociative pathway. Three dissociative pathway. So let us discuss one by one how the substitution is occur and what is the stereochemistry. So substitution in trans complexes. So we will discussing the substitution in trans complex. So we know that whenever there is a dissociation is occur, so we already discussed that whenever there is a dissociation, the intermediate with lower coordination number is formed. Okay, and let us consider the first case, that is case first. If the dissociation of x, if dissociation of x from reactant or from the complex, if dissociation of X from the reactant leaves square pyramidal square pyramidal intermediate. If dissociation of X from the trans complexes leaves square pyramidal intermediate, that adds that adds that adds the new ligand that adds the new ligand to the vacant site. That is, the new ligand means your incoming nucleophile. That adds the new ligand to the vacant site. And if you see the result of this substitution, it results in the retention of configuration. It results in the retention of configuration. It results into the retention of configuration means the product like the reactant. Okay, it is trans. So whatever the stereochemistry of the reactant, same is the stereochemistry of the product. Okay, when the dissociation of X from the reactant leaves square pyramidal intermediate. So we know that whenever there is a dissociation, the lower intermediate coordination number species is formed. The intermediate with lower coordination number is formed, and for octahedral complex which is undergo substitution reaction, which undergo dissociative type of mechanism, it will forms the lower coordination number, that is coordination number 5. And for coordination number 5 we have two geometry, one is a square pyramidal, another is trigonal bipyramidal. So we discussing the case first, that is the X will be dissociate from the complex with which leaves the square pyramidal intermediate. Okay, and in this case whenever there is a square pyramidal intermediate, then there is a retention of configuration. So whatever the configuration of the reactant, same is the configuration of the product. So if you consider, this is your metal complex and this is your trans complex. So this is your L/2. We can consider it as ethylene diamine. It is a bidentate ligand. And if you consider, this is your B ligand. Okay, and this is your leaving group, that is X ligand is there, and this is your trans complex. So this is your trans complex. So we discuss the substitution. So the first step is a slow step. It is your RDS, that is dissociation of this X ligand, and there is a formation of vacant site, So the formation of coordinated unsaturated complex. So in this case all sites are occupied by the ligand, therefore this is your saturated complex. So after dissociation it is converted into unsaturated complex, and this is a vacant site. So generation of this vacant site. So one of the site is vacant after dissociation of the X ligand from the reactor. And what happened, we already discussed, whenever there is a square, and if you consider this geometry, it is like square pyramidal geometry. So this is your square pyramidal intermediate, and whenever there is a square pyramidal intermediate, the incoming nucleophile is directly attack on this vacant site, and we get the retention of configuration. So what is the product? That is the incoming nucleophile, that is your Y. So it will occupy the position of this vacant site, and we get this, that is your En, this is your B, and this is your Y. And if you see the stereochemistry of this reactant as well as this product, so whatever the stereochemistry, whatever the configuration of this reactant, same is the configuration of the product. Same is the configuration of the product when there is a square pyramidal intermediate, and it indicates that there is a retention of configuration. So this is your trans complex. The reactant is your trans, the product is also trans. So reactant is your trans. Okay, reactant having trans configuration, and the product is also having trans configuration. It indicates there is a retention of configuration when the intermediate with square pyramidal geometry. So this is the first case. Let us discuss the second case, that is when, okay, the second case. If you consider the second case, let us consider the second case, that is case second. Case second, that is a trigonal bipyramidal intermediate. A trigonal bipyramidal intermediate. Okay, so there is a two geometry, square pyramidal and TBP. So case second, we discussing trigonal bipyramidal intermediate with, okay, so we discussing the two cases for TBP. This is your second case, and we discuss the third case. So TBP, the case second is a TBP with intermediate, that is a TBP intermediate with B. So whatever the B ligand in trigonal plane, the B ligand in trigonal plane. So this is the case. This is the case. That is when intermediate with trigonal bipyramidal geometry is formed. Okay, and when the B ligand, okay, B ligand in the trigonal plane, B ligand is present in trigonal plane of the intermediate, it leads, or it results, it leads to mixture, it leads to mixture of trans and cis. So whenever there is a trigonal bipyramidal intermediate with B ligand in trigonal plane, it leads to the mixture of cis and trans isomers. Okay, and the incoming ligand, or the incoming nucleophile, the incoming ligand, the incoming ligand can enter, can enter along any three sides. The incoming ligand can enter along any three sides of the triangle, of the triangle, any three sides of the triangle, resulting into, resulting into two cis possibility, two cis possibility, two cis possibility, and one trans possibility, and one trans possibility, one trans possibility. So we're discussing the case second, that is in which a trigonal bipyramidal intermediate with B ligand in trigonal planes leads to the mixture of cis and trans isomers. Okay, and the incoming ligand can enter along any three sides of the triangle, resulting into two cis isomers and one trans isomers. So let us discuss this stereochemistry. Okay, let us discuss the stereochemistry. Okay, so again we considering the trans complex, same complex. Okay, same complex, but in this case, whenever after dissociation, the ligand, that is B ligand in trigonal plane, so we can write the structure in such a way that, so this is your complex, this is your M. Okay, so we are discussing the case second, and this is the complex, that is M. Okay, we are discussing like this, Bx. Okay, and then this is your En, This is your En. So this is the complex. This is your trans complex is there. Okay, this is your trans complex is there. And after dissociation, so this is the complex, it is your octahedral complex. Okay, after dissociation of -6, after dissociation, okay, we know that after dissociation the intermediate with lower coordination number is formed. So we, in this case, we considering the trigonal bipyramidal intermediate. So after dissociation of X, the ligands rearrange itself into the trigonal plane. Okay, with the ligands shift their position in such a way that we get a trigonal bipyramidal intermediate in which the B ligand, it is in trigonal plane. So we get this intermediate, that is metal. Okay, this is your B ligand. Okay, so it is in trigonal plane. So this is the your intermediate. This is the your intermediate, that is, this is the intermediate, and this is your En, and this is also your En after dissociation. And if you consider, this is your trigonal plane. Okay, so we get this after dissociation of this X ligand from this complex. Okay, we get the trigonal bipyramidal intermediate, TBP intermediate. In this case, if you consider this P ligand in trigonal plane, and due to this ligand it is in trigonal plane, the incoming nucleophile may be attacked from this plane of the triangle, this plane, as well as this plane. So there is a three possibility when it attack on this triangle. Okay, so the incoming nucleophile can enter along any three sides of the triangle. So it will attack from this side, it will attack from this side, it will attack from this side, which results into 2 cis isomers and 1 trans isomer. So what is the product when it is attacked from these sides? So what you get here, if we see this, we get this, that is the incoming nucleophile, means Y is attacked and the B is shifted like this. Okay, and the remaining is your En, and this is your En when the nucleophile Y is attacked from this side. So if you consider the position of this Y and B, they are okay, they are cis to each other. Okay, they are cis to each other. And if you consider these, okay, this Y and B, they are cis to each other, and therefore this configuration of this complex is considered as a cis isomer. What happens when it is attacked from this side of the triangle? So what is the product? So what you get here, so we get this, that is Y, it will attack, and there is a B, and the remaining is, this is your En, this is your En. Again we get the cis isomers, because this B and Y are cis to each other. Okay, so this is also your cis product. And what happen when this incoming nucleophile attack from these sides? So this is your A side, this is your B side, and this is your C side. So this is the product of A side, this is the product of B side, and we considering the product of C side. Okay, so what happen when it attack from this C side? So what you get here, so we get this complex, that is M. Okay, so this Y, it will attack, there is a B. Okay, and the remaining like this. So this is your En, this is your En, this is your En. And if you consider in this complex, okay, after when the incoming nucleophile attack from this side of the triangle, we get a complex, in which B and Y ligands are trans to each other. So this complex or this species is considered as a trans configuration. So whenever there is an intermediate with trigonal bipyramidal, okay, whenever there is an intermediate of trigonal bipyramidal geometry with B ligand in trigonal plane, then there is a possibility of 3 isomers. Out of that, 2 are cis and one is trans isomers. Another possibility, that is case third, in case of this trigonal bipyramidal geometry. So the first case we discussed, when there is a square pyramidal intermediate which results into the retention of configuration. Whenever there is a trigonal bipyramidal intermediate, and the b, the main important point is that the b in trigonal plane, then it results into two cis isomers and one trans isomers. So the ligands are rearranged in the ligands are rearranged itself in such a way that we get trigonal bipyramidal intermediate, and after that we get the product, that's two cis and one trans. Another possibility, that is case third, we discussing case third. Case third. So what is this case third? Case third with the same geometry, that is trigonal bipyramidal geometry, but only difference is that b is not the part of trigonal plane. So this is the difference. So in earlier case, in case second, when we considering the trigonal bipyramidal intermediate, in this case, in that case, the b ligand, it is the part of trigonal plane, but in this case we considering the complex in which the b ligand, it is axial ligand and it is not a part of the trigonal plane. So this is your complex, that is bx, and this is your en, this is your en. So this is your trans complex. Again we considering the trans complex. Okay, after dissociation of x, we get again trigonal bipyramidal intermediate, but the difference is that b ligand is not a part of trigonal plane. B ligand is not a part of trigonal plane. Okay, so after dissociation of x, we get the intermediate. Okay, we get the intermediate like this, that is your metal. Okay, this is your metal. So this is your trigonal plane. Okay, so this is your b ligand is there. After dissociation, we get this, that this is your en. Okay, and this is also your en, and if you consider, this is the plane, trigonal plane. Okay, the intermediate having trigonal bipyramidal geometry, but the b is not the part of the trigonal plane. And in this case, if you consider, there is only two sides. So this side is occupied, so the incoming nucleophile attack from this side of the triangle, and the incoming nucleophile is attack from this sides of the triangle. One side is blocked, and we get only the true product. We get only the two product, that is we get the first product. If you consider, this is a side and this is your b side. So what you get here, so this is your metal, this is your b, and this is your incoming nucleophile y, and the remainings are, and this is your en, this is your en. So again, this is your cis isomers. Okay, and when it attack from this these sides, so what you get here, that is m, this is your b, this is your y. Okay, and this is the remaining, this is your en, and this is your en, this is your en. Okay, so this is the complex, and again in this case, this b and y again are cis to each other. So in this case also there is a cis isomer is obtained. If you consider, so we are considering the three cases. The case first, that is having the intermediate having the geometry square pyramidal with retention of configuration. So whatever the geometry, whatever the configuration of reactant, same is the configuration of the product. In case second, we considering the trigonal bipyramidal intermediate having the b ligand is a part of the trigonal plane. Then there is a three possibility, two cis isomers and one trans isomers. And in third case, when the b ligand is not a part of trigonal plane, then there is a two possibility, that is cis isomers. So if you consider, uh, as compared to the case third, case second is more likely to be occur, because if you consider the rotation, in case second there is only 30-degree rotation, 230-degree rotation of the ligand, but in case third there is a 90-degree rotation of this nitrogen of ethylene diamine, and therefore the case second and case first mechanism is most probably mechanism, or most probably the stereochemistry of this substitution reaction. So this is all about, so at least you understand, whenever there is square pyramidal intermediate we get trans product, that is a retention of configuration. Whenever there is a trigonal bipyramidal geometry of the intermediate and the b ligand is a b ligand in trigonal plane, then we get two cis and one trans isomers. And in the third case, when the b ligand is not the part of the trigonal plane, we get cis isomers. And the case third is not mostly occur, mostly whatever the dissociation, it is through square pyramidal and trigonal bipyramidal intermediate with b in trigonal plane. Okay, so these are the two expected stereochemistry mechanism for this substitution reaction. In the next lecture we're discussing the substitution in the cis complexes. Okay, thank you.